we move into the section on equations, it is so important that you have a good foundation and a very good grasp of equations, because this section sneaks into every other section of mathematics. So let's start and just identify the different types of equations, because if you can see what kind of equation you are dealing with, you generally will know how to tackle it. So the first type we were exposed to would have been the linear equation, and you would have had something like x plus 2 equals 5x minus 15 or something like that. This is linear because x is to the power of 1, and so you would simply have all your x's on one side, all your constants on the other side, and you could solve. The next type that we got introduced to was this type called quadratic equations. Okay, and quadratic equations, they deal with square unknowns. So x squared plus 3x plus 2 would be one such example. Okay, and in order to solve these, we need to factorize. Okay, and we can only factorize once there is 0 on the one side. So make sure it is equal to 0. Okay, so that we got exposed to already in grade 9, and we've been practicing those. Next up, exponential equations. So that's when your exponent is an unknown. So 2 to the x is equal to 8, for example. So there we would then get prime bases, and we would then be able to solve an exponential equation. So again, the unknown is in the exponent. And now in grade 11, we are going to be introduced to this new type, which is going to be a surd equation. So we could have x plus 3 in a root sign is equal to something, let's say 25. And then to deal with that, we basically, just like with most equations where we work with opposites, we would do the opposite. So what's the opposite of a root? Well, this is a square root. So the opposite of that is to square. And then the golden rule of equations that our teachers have been telling us since grade 8 is that what we do to the one side, we do to the other side. So surd equations, once you've followed this process, they generally unfold and become either linear or quadratic, depending on whether you have an x squared or just an x. So you'll see a few of those later. And then something you should have been exposed to from grade 9 is this thing known as a simultaneous equation. So you would have more than one equation to solve. So they could tell you x plus 3 equals 7 and y plus 2x minus 1 equals 0. And then what you would do is you would be able to solve for x and y simultaneously. And as we grow in our knowledge of equations, these two that you'll be given will also grow, so they'll become more complex. Let's dive into a couple of examples. Solve for the unknown, 3x squared minus 23x plus 14. The first thing I do is I notice that there's a square here. So that means this is a quadratic equation. Okay, and I need to do two things there. I need to check that I've got a 0 on one side, and then I am ready to factorize. So that's always my step when I deal with quadratic equations. Okay, so 3x squared minus 23x plus 14. I'm going to check, is there a common factor? Because remember, that's always our first step when we factorize. Okay, 3, 23, and 14. Unfortunately, there are no common factors there. So now we need to factorize based on the fact that we have a coefficient here of x squared and then our final term over there, which is 14. Okay, so what we do is we're going to say what multiplied by what would give us 3x squared. Okay, so 3x multiplied by x would do that. And then we choose a factor pair that would make up 14. So it would either be 1 times 14 or 2 times 7. Okay, and it doesn't matter which one you choose. If it doesn't work out, you go and you try the next one. So let's try 2 times 14, or 2 times 7, and see if we have any luck there. So what we're going to do is we're going to cross multiply. We're going to say 3 multiplied by 7 will give us 21x. And then we're going to cross multiply the other two. So x multiplied by 2 gives us 2x. And then we ask ourselves, how can I use a 2x and a 21x to make minus 23? And the answer is that both would be negative. But then remember, the signs actually belong here between the factor terms. So these terms here were just a guide for us to see what signs to choose here. Right, so now I can actually just write my two brackets. So the one is 3x minus 2. The other one is x minus 7. And that's equal to 0. I can do a final check. Minus times a minus is a plus. 2 times 7 is 14. So I'm definitely on the right track here. And then I can break it up. Okay, because what do we know? We know that if we take something and we multiply it by 0, it equals to 0. So the theory here behind factorizing this is that we can then equate these brackets to 0. So either 3x minus 2 equals 0 or x minus 7 equals 0. And then I can simply solve this. So x is equal to, take the 2 across and divide by 3. Or here, x is equal to, take that minus 7 across. Here's another example. Let's take a look at this. So it looks like it's kind of already factorized. And we might be very tempted to divide by 2 and then factorize this and break things up. But remember, there were two things we needed to do. We needed to say, okay, this is quadratic, and so therefore I need to make sure that the one side equals 0. Okay, that's not the case yet. And once I've got that, then I factorize. So what I'm going to have to do first is I'm going to have to do some distribution. This 2 is going to have to multiply into this bracket. And then I'm also going to need to look at the terms on the right-hand side here, and they're going to need to shift across. Okay, so let's get going on that. We're going to have a 2y squared minus 10y plus 4 is equal to y minus 1. Now let's get this y and the minus 1 across. So we're going to move them. This is going to become minus y, and this is going to become plus 1. Okay, now we can collect our terms again. So we'll have a 2y squared minus 11y plus 5 equals 0. Okay, now I've got 0, so I'm off to a good start. I need to now check, is there a common factor here? And unfortunately there isn't one, so let's use the factors of 2 and the factors of 5 to help us factorize here. Okay, we can break that up into 2y times 1y, and the 5 we can break up into 5 times 1, and then let's see how we go when we cross multiply this. So 2y times 1 gives us 2y. Y times 5 gives us 5y. Can I use a 5 and a 2 to make a minus 11? In this instance, I can't. And so what I'm going to do is I'm going to try and switch around my factor pairs. So I'm now going to say, okay, well, let's use 1 multiplied by 5 here for the last term. So I've just changed the top and the bottom. Okay, the process is going to be the same. 2y times 5 is 10y. Y times 1 is 1y. And can I use a 1 and a 10 to make a minus 11? I can if they are both negative. So remember, we take then the negative that we want, and that becomes the sign inside the brackets. Okay, so now we are ready to factorize this. It's going to be 2y minus 1 and y minus 5 equals 0. And then once we've done that factorizing, we can break it up and we can say, well, either 2y minus 1 equals 0 or y minus 5 equals 0. And now what we've got is two linear equations, and we can simply solve that. So this will be 2y equals positive 1, and then we're going to divide both sides by 2, so y equals to a half, or over here, y equals to positive 5. So far, there's nothing that we haven't seen before. We've been exposed to these quadratic equations, and we should by now be good at this factorizing thing. So let's take a look at these surd equations now. So we've got inside a square root, x minus 3 is equal to 2. And then we'll get to this one now. inside a square root, minus z minus 1 is equal to z plus 1. Okay, what we said was, in order to solve this, we want to do the opposite operation. So we want to get rid of the root, so we're going to square it. And what we do to one side, we do to the other side. So this is now simply the root and the square are going to cancel one another out. And so we'll end up with x minus 3 is equal to 2 multiplied by itself, so 4. And this is now a simple linear equation. Move that minus 3 over, and x is equal to 7. Okay, and the next one, we are going to apply the exact same process. So what we need to do is just make sure that we're dealing with a square root. If this were a cube root, we would cube both sides to get rid of it. Okay, so we're going to square here and square here. All right, this is going to fall away. Minus z minus 1 is equal to, and now be very careful, grade 11s. Z plus 1 squared does not simply equal z squared plus 1. Okay, that whole bracket needs to be multiplied out. Okay, so we're going to use what we used to use in our junior days when we used to use FOIL. So we will have minus z minus 1 is equal to, and then we're going to go first term, z squared, outer terms plus 1z, inner terms plus 1z, last terms plus 1. Okay, I have now spotted a square term here. So that means I want to have 0 on one side and everything else on the other side. Okay, it's definitely easier to factorize if your square term is positive. So let's leave that on the right hand side, and let's move this minus z and minus 1 across. So they're going to become plus and plus. Okay, let's make a note of that just here in yellow. Plus z plus 1 once they've moved over. Okay, so we'll have 0 is equal to z squared, and then we've got a z plus z plus z, so that's going to be 3z, and then plus 2. Okay, and now I'm ready to solve this thing. Fortunately, there's no coefficient there of z squared, so I just have to take the factors of 2, 1 times 2, and I can straight away factorize this thing. We're going to have z and something there. Okay, a 1 and a 2, those are my only factor options. And how can I use a 1 and a 2 to make a positive 3? Well, I'm going to add both of them. Okay, and then the question was to solve. So I can't stop here. I now need to say, well, either this bracket equals 0 or this bracket equals 0. And once I do that, I can break each of them up and solve the equations as needed. So z plus 2 equals 0, z equals minus 2. And there we have it. So a third equation can either be linear or it can end up being quadratic. Be very careful when you have more than one term to square. Let's have a look at one last example. Okay, we've got 3x squared in a root minus the root of 12 is equal to 0. Okay, so what we may be tempted to do here is to pop down a big square, and we're going to say square both sides. But we are definitely going to complicate our lives here because we're going to have to FOIL this thing, and we're still going to be left with roots in our answers if we do that. So my advice would be to get one root on either side of this equal sign. So if we take this minus 12, minus square root of 12, and we move it across, that's definitely going to become a lot easier to solve, because then on the one side of the equal sign, we'll have the square root of 3x squared, and on the other side we'll have is equal to the square root of 12. And now I'm ready. I can square the left and square the right. And in both instances, the square and the root will cancel each other out. So we'll have 3x squared is equal to 12. And then it's quadratic. There's an x squared. So what I need to do now is move this 12 back over so that I can definitely factorize this thing and have 0 on one side. So we'll have 3x squared minus 12 is equal to 0. Okay, I can see a common factor there of 3. So we'll end up with x squared minus 4. And then we can actually divide both sides by 3 because there's no x there. we're allowed to get rid of it. Okay. What is 0 divided by 3? It's simply 0. So x squared minus 4 equals 0. And now this is a difference of squares that I can factorize. So x plus 2, x minus 2 is equal to 0. And therefore, x is equal to minus 2 or x is equal to positive 2.